a bunch of meetup.com and Eventbrite. So it's gonna be messy, a lot of meetups. So I recommend the first one, which we curate. So to make around some house rules when we do our DevOps meetup. No, this kind of which one is better, Docker or Kubernetes?
Terraform.
Because why? Because we know Docker is better. So. And basically no backshading, right? How we use it.
Can you give me the other one?
And then respect opinions. Yes. Oh, okay. Right. So respect opinions, agree to disagree. What I recommend the audience to do is just, just chip in or whatever, just interrupt, ask questions anytime, right? That's the comment we're going for. Not just because we come from after work, right? Usually these meetups, it's tiring to hear about lengthy 1 hour session. So we keep it short, like 20 minutes, and we encourage participation from you guys. So please do, right? And thank the organizers and sponsors before you leave if you can. Thanks. Yes, thank you, Michael.
The funny part is that it seems like
okay. Are you ready?
Probably not. You told me yesterday. I wasn't really prepared.
Well, it's good that you were able to come at such short notice.
So
yeah, our
I'm introducing this bus corner for I'm planning to keep it for the next meetups as well. So what this is just some headlines of sorts. That is what's happening around the DevOps meetup. So if you guys want to, I'll ask some if you guys have anything to add. But if not, it's going to be just like 10 items, very quick, 5 minutes, right? Bus corner. So firstly, Roadrunner is like the hype past few weeks. They claim that this who knows what Roadrunner is? Is a PHP server written in Golang. They claim it's 10 to 20 times faster than a normal PHP. Yeah. Where it's on the internet, it must be true. Anyone has any? They claim it's production ready. Anyone have used it? No? Too bad. Right, check it out, GitHub, Reddit. I'll share the slide later. And then there's also Go CD, shared by someone in the engineer's mind, I think. It's a Golang CD, obviously. It's a set name. Anyway, some negative feedback from this, saying that it's hard to use. I've never used it. Anyone?
It's Go. How
Yes.
hard can it be?
Yes.
I mean, so far it's okay. It's it's okay. It's easy. I haven't run into like serious issues with it yet.
So you use Go?
I don't use Go. I just use Go CD.
Well, Go, you mentioned Go CD is Go. No, I haven't used it myself. So you just pasted it here, you don't know what's Go CD DevOps.
I don't know if it's Go or not. I mean, it's already, pipeline is already done.
Thanks, Mandy. So you basically trying, it's good, at least we learn something. Thanks. And then some guys who didn't like the Go CD recommended or suggested this, I think. Concourse CI, if you guys want to check it out, I haven't. Anyone? Concourse CI? No? And then there's GitHub Actions this month, right? They launched. Anyone use it?
I got a question.
Come on.
if you guys have been in DevOps in terms of continuous delivery and everything else, if you have been used to any of the continuous distribution products, in our case that we use Jenkins, why would anyone want to actually, what are the pain points that prompted anyone to look into CI/CD by other products? Is it that painful?
So you're asking why not stick with like existing Jenkins?
Correct.
Why use new ones?
Jenkins sucks, but there's a different story.
Anyone want to answer that? Share?
You guys use Jenkins, right?
Choose the solution.
Or something else?
I think we used Jenkins when we set it up at my last job, basically because it sucks, but it sucks in a way almost everybody already knows. It's really hard to do CI without something being broken, and a new product is usually broken in new ways, so people don't know them yet. So there's usually a horrible breaking in period. Jenkins, you have to set up all the configuration because it's not already done for you, but most everybody has done that, and anything you work on, somebody's done that.
Exactly. Really good point. Yes.
What I observed from our end is language support. Like some of the delivery engines don't support all of the languages that are out there. Like when we switched from Ruby to Elixir, we kind of faced challenges with the platforms that supported Elixir in deployment, and so we had to look around for other options. And I think that is what prompted us to look around for other CI/CD.
I guess I just want to add on here is that one of the things you mentioned about one of the original topics is that using Docker. So once we got used to all the problems and ins and outs of Docker, which is a lot of outs, is that it doesn't really matter anymore once our Jenkins script process is actually building the Docker images. Is that it does not matter any language you're using, as long as you can build an image, you can deploy, you'll be able to deploy Stack on Terraform or some other things to be able to deploy anywhere. So in the sense that if you're already used to Docker, sometimes some of the feature sets by those CI/CD solutions out there, they're not as attractive because you already spent time and effort just to actually cram it into a Docker image most of the time, in my opinion.
But I'm still quite surprised. Nobody here use GitHub, paid GitHub plans, the company, everybody GitLab, Bitbucket. Right. And kind of interesting to note AWS Lambda now up the runtime from 5 minutes to 15. That was one of your blocking longer before that. Yay. And then there's this solid, it's not the usual solid we know, but it's a social link data by the creator of www. Anybody heard of this? So can you like briefly tell us what it's about?
What I know, this thing is they research in the uni, and then they start this project to ensure our private data can be controlled by ourselves. This is their main idea for us. This is what I know.
How is it?
There's an engine, but I'm not really sure how it works. But I didn't study it.
So it's backed by MIT. The prof took some sabbatical leave and started a startup called Inrock. That this startup will be focused on working on this. It will be part of WPC. So interesting stuff. It's pretty recent, I think, few weeks. And then, Telegram group, someone just mentioned the Slack CLI, this pure bash. Maybe if you want to integrate easier with your CI, with your Slack channel, just assuming everybody is Slack. And also interesting to know Postgres, SQL, 11 channel availability. Be careful if you don't pin down the version. Stop procedures. And then I just want to mention this is pretty cool. All day DevOps is over now, but if you go to the site, you can like watch the stream. All sorts of companies participated, even the big ones like Netflix. They talk about their DevOps stuff. They recorded everything, so you can go and watch all day DevOps. Really nice. That's the end of the bus, and we will go to our first presenter, Ali.
Yeah, we'll just connect your.
Okay.
Thank you.
Yep, you can go and then. Yeah. Right, and then show that. Perfect. Yes. Good. Thank you. The clicker. Yeah. You have a pointer as well.
Hello everyone. My name is Ali. I'm working as DevOps / SRE in Grab. Today I'm going to talk about Terraform. Sorry about the short slides, and all information is really short and sweet because Ahmed told me yesterday to present, and I only had one day to prepare the whole slides. So probably it will be nothing much about Terraform setup in Grab. I'll try to describe about our Terraform setup later on once we finish, but it's not mentioned in the slide, so I'll try to present it out. So before I start, who knows about Terraform? Wow, I expect more. Who did try Terraform first? Okay, yes. Who applied Terraform in their company? 1, 2. All right. X company, that's great. Actually, I have a question for you. We'll ask you later. So first of all, Terraform is too small. Can you guys read? Should I increase the font, or is it? All right.
Yeah, I think
so Terraform is infrastructure as code tool. So you can basically write the entire infrastructure for your services as code. So you can commit it in GitHub or GitLab and track the history of all your changes for the infrastructure.
Ali, can you give 2 alternatives to Terraform? It's probably easier.
Sure. Once I finish this slide, I'll talk about the other alternative, but not all of them. Is that covered? Yeah. So the other thing about Terraform is that when you change the code, you can actually execute Terraform plan just to dry run and see what are the changes that after we make the changes will happen on your infrastructure. You can generate resource graph, which is we'll not use it in graph. Also, you can track you can also configure automation for your most changes. For example, in Grab, the most common thing is create security rules. So service A want to talk to service B. We are creating a generator that generates the code to allow service A to service B. So basically, you can automate your code generation. So that is possible using Terraform. So what are the alternatives about other than Terraform? The big one is, especially from AWS, because most of the people around use AWS, it's CloudFormation. We did use CloudFormation initially in Grab, but the limitation with CloudFormation is it's either use JSON as configuration or YAML. And the language that you configure the CloudFormation is really, really hard to implement and automate and use modules, etc. So for that reason, we switched to Terraform. We still use CloudFormation, but not in all the infrastructure in there. The other option that you can do is you can configure your configuration management, for example, Ansible, Puppet, Chef, to either manage your resources in your cloud provider. But the bad sign about it is those configuration management is not tied for the cloud. So, for example, one thing that we managed before using Ansible, not Terraform, is creating, for example, the launch configuration or ASU. Ansible doesn't keep state of what has been changed on AWS and what are the resources that it managed. So it creates the resource once, it creates the ASG once, and doesn't track of that resource. However, Terraform, it keeps track of the resources that it managed. And if someone changed anything on the console, on AWS console, or any on CLI, Terraform track the changes and tell you, hey, this has been changed, and I'm gonna overwrite it to my configuration. So the good thing about Terraform, it keeps track of the changes, and it makes sure whatever you have on your cloud provider, whatever you have in your configuration, is in the cloud provider. Does that cover that question?
Yeah.
All right. All right. So why Terraform? So there is a couple of benefit that when you use Terraform. Is the most important one is you can provision the entire infrastructure using your CLI. You can configure, provision the entire infrastructure A to Z using Terraform. Disposable environment. So the important thing that we want to use Terraform in Grab is to create multiple environments on spot. So for example, one of the things that we want, so we have staging and production. But we want to create another environment. So if you want to provision the entire environment, it's really hard to implement it if you don't have any automation for your entire infrastructure. So Terraform helps with that. So you can spin up the entire infrastructure that you have with your Terraform configuration. Preview changes, I mentioned that. So basically you can create the code, change the code, and then do Terraform plan to make sure the changes that you made is actually correct and doesn't break anything. So that really helps when a developer or engineer make a commit on your branch, on your repository, and then you make sure that the changes that the developer changed won't break the infrastructure. You can track the history, you can check what happened and why it happened through Git logging, because everything is committed into your ECS. Infrastructure consistency. So basically, for example, you have a best practice infrastructure. So you create ASG and with LC, launch configuration, and on top of it, you have an ELB. You have some IAM roles and policies and everything for your infrastructure. So basically, you can clone this over and over and over for every service that you have. So if you, in the future, encounter something new, like AWS recommend you to do something about the IAM policy, IAM role. So instead of doing them for every service manually, you can basically change the things on one module and it will apply among all the services that you have. And this is what's really cool about Terraform. Multi-cloud deployment, we didn't reach that in Grad, but we are aiming with Microsoft actually to provision multi-cloud with Terraform. Terraform support that. Terraform support multiple providers, not only AWS and Azure, Google. It supports many providers. I will talk about providers later on. Any questions so far? Yes.
Do you use any tool to verify, like I should not open my security groups for the public? So is there any tool which verifies this configuration of Terraform?
Good question. Actually, we don't at the moment have any configuration or any tools that does that. Excuse me? Yeah, there is a lot of tools does that. One of them, there is one called. Yeah, there is one of them is also TF-lint. So you can also configure a linter and make sure that you apply certain policies that you can configure and make sure that your changes won't allow the RDS to be public, for example, or something like that. Yeah.
So let's say I'm using Terraform for AWS, but AWS wants to something
have to move without
so
shaking
how
too much.
people need accepted or how fast?
Can we postpone this question to the end? Any questions for this so far? Right. Anything? Yeah.
Because the configuration of the script is because the Terraform configurations is everything is in the script, so we would typically check into our code repository. So if you have a good PR practices or code review practices, these are the stuff that you would normally catch. Then before even you allow the changes to be merged into your branch.
Good point, actually. All right. So what Terraform is not a configuration management. Terraform is not Puppet or Chef or Ansible. So even if you have Terraform, you still need the configuration management to, once you provision the EC2 instance, you need tools to configure the EC2 instance and run and apply and deploy the services in those EC2 instances. So you still need configuration management. Terraform won't remove that from your infrastructure. Terraform won't remove Kubernetes, so you still need, if you have Kubernetes or any Docker automation or orchestration. Thank you. You still need that. Terraform won't remove that from your infrastructure. And CI/CD as well. Terraform won't remove those. But you still can depend on Jenkins or any CI tools that you use in your company to actually Terraform plan and make sure every PR or merge request actually Terraform plan and make sure the result of the Terraform plan is okay and there's no problem with that. All right, what are the providers? So as I mentioned, the most common one is AWS, which what we are using currently. But you can actually use any other providers, any cloud providers like AWS or Google Cloud or Azure or DigitalOcean or anything else. It can also, it has service providers like PagerDuty, like Cloudflare or Datadog or any other providers as a services. Those providers require some time of authentication, so if you are configuring Terraform with AWS, you need to provide the AWS key with secret as well when you do Terraform plan and apply. All right. So after you configure the provider, let's say that you configure AWS, Terraform treats any resource. Resources in Terraform is actually all the components that those providers provide. For example, an EC2 instance is a resource. An RDS instance is a resource. A VPC is a resource, etc. So any of those is actually a resource type in Terraform. So, for example, in this example here, in the code example that I have, we have an AWS instance, which is, for example, here it's called web, and it uses MI with an instance type 21 micro. So basically, any resource in Terraform, anything that it managed to treat it as a resource. So not only physical things or virtual things, it's also anything, for example, PagerDuty. If you have, for example, PagerDuty schedule or nurse or anything like that, it treats any of those components as a single resource. Right. So when Terraform, when you have all right. When you have a configuration that creates EC2 instance, when you tell Terraform, hey, go apply the changes, it goes and creates the EC2 instance for you. Once it's finished, Terraform creates a state file. The state file is, as I mentioned, the differences between Terraform and configuration management. It doesn't keep the state of the resource. Configuration management, whenever it creates a resource, it just vanish from its memory. So it doesn't track anything changed of that EC2 instance. However, Terraform, it keeps track any changes happen on that EC2 instance. So if someone changed anything on the EC2 on AWS console, Terraform next time it goes and override the changes to whatever it has in the configuration. If you do any changes on the configuration, for example, you add a new tag or you add a new security group on the EC2 instance, the next Terraform plan and apply, it tell you, hey, I'm gonna only add the security group. I'm not gonna create a new resource or add the tag only for the random EC2 instance. So basically keep track of that EC2 instance and make sure that changes that you make only happen on the EC2 instance. One important thing for the state file, a lot of newbies does it, which is they commit the state files into Git repository. Don't do that. It's a really mistake. It's a huge mistake. So because if you work in a team, it's really important to have the state file shared between all the team. And if you put it on Git repository, it's like every time you make the changes, you need to push it to the Git repository before anyone else from your team has the latest update of the state file. So the best practice, at least you can use S3 bucket and store the files in the state files in S3 bucket. Some providers, some state files, they use locking. In Grab, we use Terraform Enterprise, which is the paid version of Terraform. It will give you like a UI and you can see workspaces, etc. One of its features is it's provide locking. So anything from anyone from the team, if he's Terraform apply on that workspace, if someone else is trying to apply at the same time, it will prevent him from overwrite the changes that the first person is doing. Modules, what are modules? So I mentioned about the resource. So you tell Terraform, hey, I need to create an EC2 instance. A module is a set of resources. So for example, if you have a module, we have a module in Grab, create an ASG with launch configuration as well as ELB all together with IAM roles and policies, etc. So all of those resources tied into one module. So any other services want to use this module, they basically just point to the module and they use the latest version of the module and get all the resources that we provide in that module into their services. Modules take parameters as an input, as a variable, and present an output. For example, if you are outputting the security group ID or if you are outputting the AMI ID, etc. Depends on your module. I mentioned about plan many times. So plan basically, it's like a dry run. It doesn't actually execute the changes. It just tells you what exactly will happen when you apply the changes that you made in the code into your provider. Terraform apply is actually execute the changes into the provider and make sure that the changes has been applied, and it tell you there is the update after it's finished. It's already updated the resource or not. All right, almost there. I don't know if you guys still see that it's very, very small. What we have in our repository for the Terraform code is basically we have common modules, like you see Terraform and then another directory called common. And every common resources for AWS, we have it in that directory. For example, we have under storage, we have an S3. So any service need an S3 bucket. Basically, they don't need to create it on their services. They can actually refer to this S3 module. If they need, as I mentioned, the ASG, LC, ELB, if they need that, basically they can just simply refer to their service to this module, and then we'll create all the resources for that module. And then in the board directory is that we have the service A and service B. And each one of them contain at least the modules. Under the modules, we separate the compute modules than the data modules. So for example, RDS live on data modules, EC2 or ASG live in the compute modules. And then under the service, we have production staging and dev environments. Basically, those environments, they refer to the modules that we create under the service. So if you want to create another environment, like let's say pre-prod or QA, basically we add another directory here and we refer it to the module of the service. And then it will create the service for us, for that environment. And then we have any other services that we have. One of the services that we have, which is the most important one, which is the network, we call it cluster. So basically that one create the VPC, create the subnets, the route tables, etc. This is the most important thing before you actually create any other services on top of the network. As I mentioned, the common modules that we have, we have at least the common modules that we provide in our repository. The one I mentioned many times is the ASU with LC and ELB. We have MySQL with replica. Basically, this module creates the master replica, the master RDS, and then it creates multiple replica, read replica behind it for the application for select queries, etc. Almost there. The last thing that we have is for web apps. For example, if you access grab.com, it's basically all the code written in S3 bucket with a CloudFront on top of it. So this module provides this for all the web apps that we have in Grab. As I mentioned many times, every time we have a merge request or pull request, we configure the GitLab in our company to integrate with Terraform Enterprise. So every time we have a merge request, we actually go in Terraform plan all the workspaces for the services, and we make sure that changes that doesn't break anything in the merge request. Yeah, that's all. Thank you.
Alright, so we open a 10-minute session for Q&A. Ivan, if you want to set up, we can. So, question. I have one. Alright. So, how long have you guys used Terraform, and personally, how happy are you?
We start working in Terraform since I joined, which is almost a year. And we recently migrated all the services that we have into Terraform, which took us like almost a year work to manage everything into Terraform. And import everything to
how many in your team?
The team is at the moment is 8 people, but initially we were like 1 or 2.
No. What slides or what do you have?
We are very happy with it.
I'll just put here markdown. I only have one question. Just pass the markdown on this show. So you're not going to be able to fire to that.
You use models from the Terraform community, or do you write your own custom models all the time?
Good question. So we use only one module from the open source community, which is the RDS. But then we had limitation with that because we have a lot of things that depends on that module, and every time we push an MR or a pull request to that GitHub repository, doesn't go and push to the upstream. So for that reason, most of other modules that we have is built in-house.
Doesn't have it.
No plans to open source.
I don't have a
probably yes.
Do you face any challenges in terms of scaling up applications?
You mean the services, the applications, or Terraform?
I mean the services.
So services, if you want to scale up basically for your infrastructure, is basically you can add, for as you maximize the maximum, you make sure that you have a good maximum infrastructure. So we don't have anything tied to Terraform regarding scaling out the services.
My HDMI is good. You can just that's fine.
Since you mentioned that when you started doing the Terraform stuff and everything but how about the services which are already running in the cloud, and as well as the infra which is already created? Since you're doing Terraform for it, how you manage those things, how you imported all those things into Terraform in first hand?
Very, very good question, because so Terraform is really nice if you are creating the resources from Terraform itself. However, if you have already created resources on your AWS cloud, it's very, very hard to import those resources into your configuration. The way we end up trying many methods. The way we end up doing is there is a tool called Terraforming. It's an open source tool, Terraforming.
Bunny is not okay.
Okay, it's an open source tool, it's written in Ruby. So we use that tool to generate all the code, all the configuration for all the resources that we have in Terraform. In our AWS, and then we create a tool that split because Terraforming generates few services dump files. So for example, to create an ASG TF file with all the ASGs that you have in your AWS account. Then you create another tool that split them into their own services directories. That tool is only for Terraform because the splitter is only typed for Graph actually. However, the first tool is called Terraforming. We use it just to import and dump everything from AWS account into Terraform cloud.
How about the cost Terraform also gives an option of Terraform import? Have you tried that?
Yeah, definitely. So when you generate the code of the resource that you want to import, you run Terraform import after that. And then you do Terraform plan just to make sure that you are having zero differences between the Terraform code and what you have in AWS.
Okay, can I make it a slide?
So Terraform makes sure that all parameters are there, exactly what we have in
what's the program?
Thanks.
Spell SENT.
Alright, one last question. Anyone?
Anything you can install. In the Git code, everything installed.
So how do you make sure that something new AWS Terraform supported?
Okay.
Something very new. And my second question is, how do you maintain that nobody touches your infra? Or anybody do it installation of the Terraform, or you have to just the Terraform and don't touch your infra?
Right. So the first question is, how do you make sure anything from AWS is actually in Terraform? Basically, Terraform or HashiCorp, they really follow up AWS when any changes happen from any providers. And they make sure that any new resource is actually in Terraform before it's actually announced in AWS. So they always follow up with any new services from AWS and any other provider. Never face any issues with Terraform. However, we face a couple of issues. For example, Terraform import doesn't import from all the resources that you have in AWS. Then we come with actually a couple of pull requests to Terraform to make sure that we have those Terraform imports for those resources. The second question was, how do you make sure no one changes on AWS not using Terraform, right? This is what we are facing at the moment. A lot of people has write admin on the AWS console because we just recently switched from AWS console to Terraform. People still try to go to the console and click and make the changes. Every now and then we face a couple of problems. I think the best solution for it is to prevent any people remove all the admin keys from every users and then let them force them to use the Terraform. But there is no solution for that at the moment unless if you tell or coach your team not to do anything on AWS.
Alright, thank you, Adi.
Thank you.
I'm not going to beat it for me.
So by right, we have like a 10-minute break, but I think we can skip that.
Just close the left side.
The 10-minute break should have included some session or job as I'm going to move that towards the end. I'm just concerned about those who really want to go back. So the next topic is
let's go.
serverless topic. Ivan is going to share his experience using and deploying serverless tags.
Yes, he needs this. Can you give him? Can you give him? The mic is there. It's already casting to this thing. Oh, alright, okay, insane. Oh, I think, wait, just give me a second. It's the wrong thing plugged in. Yeah, so let's go to something is wrong here.
Today I'm going to talk about the serverless architecture.
That's the old one.
And the slides is a bit. Yeah, alright. And I'm currently I'm studying in data analytics degree, and I'm also working as a research assistant for NTU. We use the old in-house, like the old in-house, like the database or it's in-house, but then maybe because the in-house is not performing that good, like the database, they are slow. Like after a few years, they become slower and slower. So we try to move to use the serverless architecture. And for some that we can't switch to serverless architecture, we try to use EC2 and the AWS provider with the automatic product with some Elasticsearch services. So mainly here we only use AWS. We don't use Lookup and the Azure. But then our stack mainly last time we used Node, but then at the end the developers decide not to use Node because the error reporting is a bit harder and most of us has the skill in Python, so we decide to switch to Python. And why serverless architecture? Does anyone here uses serverless or tried serverless architecture? So basically, why? Because my boss says so. That's the first reason. And the other thing is we have a lot. The cost reduce a lot, and by the cost means the visible cost. There's also hidden costs like the charges on the back, like the networking and the storage, but that's not a lot right now. So what's nice about serverless is that we can pay for what we use. And let's say if you use EC2, but then your EC2 is not always used to the maximum, then you waste what you use. Like sometimes there's a peak, and then sometimes the EC2 is not at a peak. Of course, there's like optimization, like using the smaller containers and then scaling it up when there's a peak. And next, if we use serverless, there's no servers. We don't need to configure servers. So mainly our development team are mostly DevOps people. We just deploy to Bitbucket, and Bitbucket helps us to push to AWS. And of course, it keeps developer busy because it's like very troublesome to use and very hard to use compared to like if you host your own servers, very hard to use, very hard to debug, harder. And now today I'm going to share about the serverless frameworks here. And why serverless? Because it's infrastructure as a code. We can put it to host it as a Git repository and host it on small projects rather than just directly modifying in AWS Lambda. Like if you modify this and next time you doesn't know why is the change, so you can track all the changes in the Git repository. And the first one I'm going to introduce is Chalice. Anyone heard of Chalice here or use Chalice? Chalice is a Python framework officially supported by AWS. And it has a class-like API, similar to class, but then you cannot just Python the app.py. There's a command to let you invoke the Chalice, and it can simulate like the AWS environment. The two main uses you can use is, one is the Lambda functions, the upload to API gateway, and the other one is the support scheduling, the AWS schedule. It's quite easy to use schedule there. But it's only limited to AWS. Optionally, for the vendors part, you need to manually handle that. Let's say if you want to have some third-party libraries that have some C plugins, like cryptography. In Python, you need to compile that, right? So you need to manually build it in EC2 or your local machine using LAMP-CI, the Docker image, and put it to the Git repository. So you need to host it manually using LFS, the Git large file storage. Anyone uses that? Git LFS? Git LFS is a tool to let you host large file to the Git repository. So next time, do you notice that sometimes when you Git clone, and you always push the changes to the large file, like the large file up to like 1 meg, and every time you change the file. And Git LFS helps you to throw all the files into another part, separate it from the history. In the history, you only put like something like the URL, something like that. They only track the metadata for the large files. So instead of pushing the large file straight to the history, you put it in somewhere else, but then it's automatically handled by the DevOps. And also I've contributed to the checklist, but then they are not quite active. I sent a pull request for the minimizing the output, but then they haven't accepted the pull request yet. So one thing to note about checklist is that you need one downside.
It's not active enough to accept your pull request?
No. I forgot to say. Yeah, by default, one pitfall of checklist is that by default, it's not using AWS cloud formation. It do some random checking in they put a deployment folder. They track the changes manually in that folder. It's not using cloud formation. So next time when you deploy to a new when you go to a new machine and you deploy it again, you'll get like a new instance of the same deployment. So it's quite frustrated. Like for beginners, sometimes you don't know like, oh, how come when I deploy, every time I go to Git, every time the Git CI deploy, and then I get a new instance. So there's one issue that beginners will face. So you need to manually enable the cloud formation using the manually enable cloud formation option arguments passed to checklist. Okay, next up is checklist. And you have a question about checklist? The framework. Next up is Zappa. Who have heard of use of Zappa? Use Zappa.
I just have one question first. All these are Python related libraries. Is that correct?
Down there have some non-Python related. But I've used that also.
So for those not using Python or related, and how would, if the serverless architecture does not support your language of choice?
Yeah, these two are not for Python. No, not for non-Python, but the others support Python. Later I'll come to that.
Moving on.
So Zappa.
I have a question about checklist, right? So why did AWS choose to support that? It's quite new, right, compared to other players like Zappa or JAWS or others.
Oh, Zappa is like a community. They build Zappa.
Shazwan is asking about chalice.
Why is it chosen by AWS?
No, it's built by AWS.
Oh, okay.
The people it's built by AWS people. So it's not chosen, it's already built by AWS. And they're just copied like the plus. And then instead of plus bracket, you get chalice bracket. And it's the same. Except that they have additional thing is that schedule thing that I mentioned just now. They make scheduling easy. Okay, so next is Zappa. Zappa is another framework. If you have heard of Flask, Django. So Zappa is not actually like a micro framework just for serverless. It leverages your existing project. Let's say you have a project in Django or you have a project in Flask. Must be WSGI based project, and suddenly you want to make use of serverless architecture. How? You just add Zappa to your project. And then it's like an add-on, you can just straight make use of the serverless architecture. So you push your code to the serverless, and every time it runs, if you call the instance again, you call the instance and run again. But one thing is that, what's nice about Zappa is that they have a hot reload by default. So a keep warm thing, like every 5 minutes they'll rerun. So that all the connection stays, because the AWS Lambda, like every 15 minutes, I think around 5 minutes or 15 minutes, they'll stop the container, and then the connections on data will be gone. So if you want to keep your connection open and make it fast, so they'll have a keep warm feature for that. So that's what's special about Zappa and that other frameworks doesn't provide. And by default, the Zappa uses Lambda packages. Lambda packages is quite nice in the sense that if you put because currently there's a rendering in Python, right? Let's say your framework, you need to use some C libraries, C extensions, like just now, like I mentioned in the checklist. Let's say cryptography, or some example is cryptography, and also like Pillow. And if you use Java, they'll do it for you automatically. So you put your files in the package, the requirements text, like log file, and Chalice will automatically install that for you using Lambda packages. So you don't need to manually build your own Python distribution file for Java. But one limitation of Lambda packages is that you can only have one version. They only provide you the latest version for each Python. Let's say you use Python 3, and then you use an old version of the Python package. You can't do that because Lambda packages only keeps the latest version. So let's say because we use the Oracle client, which is like 9, and it's a bit old. So we need to use like an older version, but Java doesn't support that. So you need to manually render it as well, because there's some limitation in the Lambda packages. Okay, that's about Java.
Wait a minute, you mentioned that you are using serverless to run your Python scripts to connect to an Oracle server?
Yes. I know. Yes.
Never mind. Didn't see that.
Okay, next is the serverless. Okay, for serverless, one nice thing about it is that it's a cross-provider. You can use serverless for multiple platforms, and you can use it with multiple languages. Usually people use it for Node.js, but here we can also use it for Python. One nice thing about serverless is that anyone here uses serverless or tried use serverless or have heard of serverless framework? Yes, serverless framework.
Yeah, formerly JAWS, and then they rebranded to serverless to confuse people. I don't know why.
So usually people use it for Node.js, but then now we use it for Python. One nice thing about serverless is that you can each access the server. Let's say we have one project that makes use of serverless, because we need to use the AWS resources to provide the IoT, like to provision an IoT platform, like the IoT resources, IoT related that. So because both Java and Chalice doesn't support like the other resources, let's say provisioning, DynamoDB, all the other stuff, serverless does that. So we use serverless for that. Originally for that, I'm looking on Terraform, which I will talk later, but they don't support that. And serverless seems quite nice at first, but then when I noticed they provide a different interface compared to the original Lambda function. Let's say original Lambda function, you have a context and you have the events, right? But serverless, I think that keeps a simple interface to unite all the different providers. So I think you'll get the same thing if I recall correctly. So like let's say if you want to do this code for this provider and then do the code for this provider, they'll unite it for you, so you have one interface. And serverless is quite easy to use. Of course, there's something easier to use, but I'll talk about that later. Any questions about serverless? Okay, so the next thing is SAM. Have anyone heard of SAM or use SAM, serverless application model? I think. Anyone tried that? It's a deployment for, it's like an extensible interface to AWS Cloud Formation. I think most of you have heard of AWS Cloud Formation, right? Who have heard of AWS Cloud Formation? Or have written AWS Cloud Formation by text? Written. Okay, so it's like an extension to AWS Cloud Formation. They do some transformation inside there, but it's also officially supported by AWS, but it's very hard to use. I mean, if you want to use it to provision something not related to API and like API gateway or lambdas, it's nice. But then if you want to do something like you want to provision an API, so it's quite frustrating at first. You take a long time to understand how to use it. So it's not quite user friendly. And of course, it only supports AWS because it's built by AWS. And the deployment, just to do the deployment, I think you need 3 steps. One, to do the YAML file, generate YAML file, and another step, you need to manually, inside that tutorial, they want you to manually push the code to S3. And then you only get to deploy the serverless. That's how that works. So serverless application model is quite hard, but if you want to make it easier, you can use serverless. Because serverless can automatically use all the resources in AWS. And next is Terraform. Okay, this is the only. Any questions about serverless application model first before I continue? Okay, next is Terraform. I think they explained about it later. Just now that it's like a standardized. It's also cross provider. You can use it for multiple platforms. And
how is serverless and Terraform related to each other?
Terraform can also deploy serverless code, right?
No idea.
No. Yeah, but they don't automatically like deploy to that. Last time I tried using Terraform, maybe for IoT related stuff, but probably not writing API. So Terraform has a quite simple syntax to write their deployment. But then one thing is that there are so many pull requests open in Terraform, and then last time I checked like 1 year ago, until now they still doesn't support the IoT platform. Like, of course they support like just the minimal. They don't allow you to do the policy generation for IoT stuff. And that's the reason I don't go so deep into Terraform, because we never really like get used to Terraform. Any questions on Terraform? Okay, next is Apex. It's introduced by one of my friends. And it's quite simple to deploy in Apex. It's just Apex up, and then you get deployed, the code gets deployed. One thing about Apex is that it's mainly used for both. That's what I know. And last time I checked, there's no Python 3 support. I also didn't look quite much into Apex. But it supports a lot of languages, but last time I checked, it's not Python 3. Okay, next thing I want to discuss is about the configuration. Okay.
Can you wrap up?
Wrap up. Is it? I just have these two. Okay, next about configuration. We are still facing issues with configuration, and we don't have a unified way to do configuration. There are 3 ways we mainly do it. One is not CI/CD way. So after we deploy, we need to manually edit the Lambda environment for the, let's say, the credentials and stuff. Some ways like this is quite bad, because like if it gets undeployed and we deploy again, the environment will be gone, and then it will be frustrated, or the developers will get frustrated, like what happened. Of course, next way, we also try to inject the variables inside CI/CD. So basically, we do a seed inside that inside the CI/CD, like the Bitbucket pipelines, we just do a seed. And another way, if you want to use a file, you encrypt the file with OpenSSL and put it inside the code. And after that, in the Bitbucket pipelines, we will just decrypt the OpenSSL file. We will put a key and the initialization vector there. And next is we can also make use of KMS, but we have never tried that. why I heard KMS is quite expensive, so I didn't get to try that.
What's KMS again?
Key management system, AWS.
AWS.
Okay,
Yeah.
got it.
And next, the issues I faced so far with the current systems. So first is the policy auto-generation. The policy generated by all these frameworks are quite wide. Let's say you want to use S3. They will give you S3, but they will give you like all the services, all the resources in S3. So you can't specifically target one single S3. I remember one of that framework is quite bad. I think it's Zampa. They give you like all the resources in AWS. They don't divide it, they just give you all the resources. But Chalice, you still can manually like configure which policy to use it. Of course, writing policy is not easy to do that. But Chalice also have their downside where they hard-coded the generator for the policy. The next is logging. I found AWS log quite useful to do logging. You can just do AWS log -f. I think it's and just for logging and stuff, but you still need the policy there. And also testing, so quite hard to do testing because they don't provide easy testing, except if you use like Flask, you can do testing there. And also documentation. Let's say you use serverless architecture, like in Python you can do the Python the PyDoc. But that one they don't provide automatically generation of the documentation. So you can't like just one step generate the Swagger, the open API out. And so all these frameworks they don't make use of Lambda stages. Let's say if you want to deploy to API or development testing, you need to deploy separately. Your code you need to build one for testing, you need to manually send to test. And then if you want to build one for production, you need to have another test and another API gateway for production. So you will see multiple different API gateway, and then that API gateway only contains a single stage, which is either test or production. This is why I see they don't make use of multiple stages. Of course, that's also hard to debug. You can't like debug online for server stuff. And also low timeout, but lately AWS increases the timeout to 15 seconds, I think, Lambda.
15 minutes.
15 minutes.
15 minutes, sorry. 15 minutes at most. Yeah, lately I also found something called serverless SSR. Anyone heard of server-side rendering with serverless? Lately in the hackathon I saw something with Vue is that there's a Vue serverless, I guess. So that they allow you to use serverless for server-side rendering. That's what I saw, but I never explored that. Yeah. Okay. Any questions?
Awesome slide, by the way. Even has real-time auto correction. So I'm going to open like 10 minutes until 9 Q&A or if you want to chip in some of your experiences in serverless. One?
Well, I can project. So the guy who was asking just now about whether it supports only Python, so like it depends on the platform. I think AWS currently supports Java, Golang, what is that? Node.js, Python, a whole bunch basically based on your runtime. So don't have to worry about it only supporting Python or JS. Azure as well, sorry, as well as GCP and stuff. Yeah.
Yeah, I can add on to that. Is that if they don't support the language you want, you can always make a binary, and then you can use the Go or any runtime to just call the binary and run it. That's an additional use case where the language is not supported.
You write a C++ when it.
I can write in Rust and use it.
You're speaking from experience here.
You know that's your next Rust topic, right? Deploying Rust to serverless.
No, they don't have yet. So if I want to do it, I can only make use of the Go runtime and I call the code. Or like do FFI.
Right, so I want to ask, right, one of the recurring
points about serverless is the cost. It says reduce cost, right? But I've seen a bunch of articles claiming otherwise. When you scale, the cost also scale quite exponentially. So anyone has anything to share about that?
This was like this so we were averaging out like 100,000 lambda calls an hour, and that is covered pretty much Southeast Asia. So when we started off, we saw like use of 2,000 an hour. So there's actually a threshold where you can actually see in terms of how you actually manage your EC2 instances between the lambda calls and everything. So there is a point where you realize that having a single API to call is actually not really worth it, but you need to do a calculated point. Because it depends entirely on your code, like how big are you going to run in terms of runtime, are you going to run with Node.js, are you going to run with Java, how much of web memory are you going to put onto your lambdas, how long does it execute? Like I said earlier on, there is a lot of hidden costs that hides behind all that. So it's pretty much straightforward. So. But yeah, that's what I experienced. So what we did was like we identified which Lambda API was incurring that cost, and we typically moved it to dedicated EC2 instance, where it's running purely Java behind it, it just handles all the calls. So
then you manage Lambda and then you manage it.
yes. Because it came to a point where it just doesn't make sense to actually do that, to actually have your Lambda to keep the cost, because the whole point of going to cloud is to reduce your cost, your total ownership of right? So we pretty much put it into Elastic Beanstalk if we needed skill.
Thank you. Anyone else? So when I started trying this a few years ago, one of the, I think, high barrier of entry because of the number of things you have to do everywhere to get your function, and also you touch debugging, API gateway, stages, just to get a simple thing going, you have to set up so many places everywhere, and then the tools back then to test locally was not good enough. I'm not sure now. I'm guessing like serverless, you can do something like test locally right now.
Now I think I saw something called Lam CI, which emulates the execution in AWS, but then I think they don't have the execution time support. Let's say you're going to execute the Lambda call for like 5 minutes. They can't limit that. Last time I checked, I think. Because you can emulate the same calls in AWS, but just without the time limit. So one issue we face is that sometimes we need a function to run after 5 minutes because it's a long run. It's not like really a long running function, but the first run will be longer because we have a use case where we want to generate the images and make thumbnails for caching, and we dump it to S3. So instead of fetching from our main server, like the images, we'll just scrape it from serverless, and then we process the images using Hero and dump it to the dump it to S3. That's the main use cases for the time.
Right, maybe one more. Anyone? I'll throw the mic at you, but no one can see it. Yeah. No. Alright, thanks Simon. Round of applause.
What topics in terms of what you guys are things that what you guys
Han is asking what kind of topics you guys are more interested in for future meetups.
How DevOps, how what the DevOps stuff that you know, different people have different way of learning. It will be interesting to see how the whole ecosystem will evolve. I mean, it doesn't have to be very there's some sites that they have probably something
Are you volunteering? Thank you. Thanks. Lovely. So yeah, I would like to. I yes.
I've never requested that secret.
Yes.
So like how people currently have a basic issue right now, where we got to the point where we got CI and CD, but secret management, especially like allowing my engineers to do secret management rather than me doing it, becoming an issue. So I want to like decentralize that. I don't know how people are doing it. I've looked at all. It looks like a lot of hassle to integrate. And so I'm wondering how people are doing it with their organizations. Without buying into like fully AWS PMS or like, you know,
That's right. That's right.
Yeah.
Right? Cool. Right, so before I wrap up, again I would like to beg you guys to like maybe thank these sponsors and speakers because nobody is getting paid to do this. So a round of applause to them. And then now I'm opening a 5-minute session if anybody wants to job as or share meetups before you guys are attending something. Will they come 2 days from now? And it will be, yes.
Basically, a recall is 2 days. Basically, this Thursday and Friday. We have one speaker here, so you can talk to him about it as well. If you want a promo code, especially for today's meetup, it's a Ruby Awesome, so it's 50 ringgit off the tickets. So you're coming, right? Yeah. Okay, that's awesome. Alright. If any details, just ask me around. And we have like 20 plus speakers. The keynote speakers for Kontasin Has, Group CTO of Gojek. So sorry that. IJGO is coming over as well. So and one more is Nadia, and another one is I couldn't recall. There are a lot of speakers. Yeah. Alright.
Any job as anyone hiring? No? Alright, guys, thank you. SRE role?
Yeah.
So, what's your name, sir? Ash.
Just look for me, I'm pretty tall, so like.
Alright, so clean up. Yes, finish the code. Thank you.
SD card. Yeah. And Mongoose. You just remove the bar. No, remove the bar.
Alright, so we'll just have to ask you to just clean up after ourselves. So because we're just running. I think we're done, right? Yeah. Thank you for coming. Yeah, just clean up after yourselves. Just like pack the bean bags and the stuff that we ate from. If we can just throw them out like into the plastic bags and leave them to the side of the garbage can, that would be great. Thank you and good night. Thanks for coming. Tevan. We're going to the mamak downstairs to chill out, right? So if anyone wants to go, just go.
It's food there. I'm going back, take the train back. Oh, no network. Going back, take the train back. Should have plenty of time. Join the